Hi guys, welcome back to J Sigma Math. In today's class, we're going to be talking about number system and conversion of from one binary system to the other. So the first one we're going to look at is the digits. Here on the screen we have 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, then A, B, C, D, E, F, G. So, and those letters represent 10, 11, 12, 13, 14, 15, 16 in the base 10. So let's look at what we call the base. So if you write numbers in base 2, of course, that will be the computer language, and that will be 0 and 1. So that's 0 and 1. It's called a binary number, or numbers in base 2. That means numbers that are less than 2. And if I write in base 3, I'll pick up 3 numbers, but those 3 numbers must be less than 3. So these are numbers in base 3. We have 0, 1, and 2. These are numbers in base 3. Then in base 4, I'll pick up 4 numbers, but they are less than 4. And that's 0, 1, 2, 3, 4, and so on. So if I'm to write in base 10, I'll pick up 10 numbers that are less than 10. And that will be 0 to 9. So these are numbers in base 10. So that means that, and they're also called decimal numbers. All right, so if I pick up numbers in base 10 and I want to create other numbers, all the numbers I'm going to be creating are going to be based on these 10 numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I would not exceed these numbers. But what about if I'm to write in, let's say, in base 16, which we actually call hexadecimal? So that means that I'm going to be writing this. So hexadecimal, I'm going to be having letters that involves A, B, C, D, E, F, G. So these my numbers are going to be somewhere around this. So these are what we call the hexadecimal, and we use them also in computers. All right, so we want to go fully into today's class. So I haven't gotten the knowledge of what the number system is. We actually want to go into today's class, and the first thing we're going to look at is conversion of decimals to binary. So how do we convert from decimal in base 10 to numbers in base 2? So the first thing we have to do, this is 76 base 10. We want to convert it to binary, and that's in base 2. So the easiest way to actually do this is to actually create like a cross. Create something like a cross, and there you go, 76. Since you are converting from base 10 to base 2, then 2 is going to be on the other side here. So we're going to have 76 divided by 2, that will be 38. Remember what? Remember 0. Then divide that value by 2, then you have 38 divided by 2, you have 19. Remember 0. Then you have to divide 19 by 2 also. 2 divided by 19 is going to give us 9. And that's 9 times 2 is 18. That's remainder 1. Then we're going to divide 9 by 2 also. 9 divided by 2 is going to give us 4. And 4 times 2 is 8. That's remainder 1. Then, okay, let me extend this line a little. Then let's divide 4 by 2. Then I have 4 divided by 2. You have 2 remainder 0, because 2 times 2 is 4. Then 2 divided by 2, I'm going to have 1 remainder 0. Now we get to this point that we have left with 1. So, but we still have to divide that 1 by 2. So 1 divided by 2 actually is 0.5, but in this case, we're not going to write 0.5. We're going to take it as impossible. So in that case, we're going to put 0 here. That means it is impossible. Then bring down this remainder, which is 1. Bring it here, and you have 1. So the remainder is 1. So therefore, we have something like this. So we're going to write our numbers from the bottom to the top. So that means converting 76 base 10 to base 2. we're gonna get 1001100 base 2. We've converted 76 base 10 to base 2. Then let's take another example. We have 472 base 10. We're converting this to binary. Same process. We're going to do the same process. So let's create a cross 472, dividing by 2. That's in base 2. So 472 divided by 2, that would give us 236. Of course, there's no remainder, it's an even number. Remainder 0. Then divide the same value by 2. 2 here, that's 118. Remainder is an even number, so it's going to be 0. Then also divide this value 118 by 2. You are going to have 59. Remainder is an even number, 0. Then 59 is an odd number. If you divide it by 2, you're going to have remainder. So 59 divided by 2, let me extend the line. 59 divided by 2, you have 29. Because 29 times 2 will actually give us 58. So remainder 1. Then 2 divided by 29, we have 14, because 14 times 2 will give us 28. So we have remainder 1. 2 in 14 is an even number. So you're going that 14 divided by 2 is 7. Remainder 0. 14 is an even number, so your remainder must be 0. Then 7 is an odd number. 7 divided by 2, you have 3, because 3 times 2 is 6, and that's remainder 1. And so you divide again by 2. 2 divided by 3, you have 1, remainder 1. And you have 1 as your remainder 1. So what do you do? 1 divided by 2 is not possible in binary, in conversion. So what do? We write this as 0, then bring this 1, we bring it down here. So therefore we then say that our answer, then we're going to write it upwards like that. And so 472 base 10 is going to be written as 111,011,000 base 2. So that's how to convert from base 10 to base 2. You divide by 2. From decimal to binary, you divide the decimal number by 2. So that brings us to the end of this subtopic.